So 5-9, we're talking about a specific type of sequence called arithmetic sequences. All right, so we looked at sequences yesterday for some of your problems, arithmetic sequences. So let's get a few definitions here. We call a branch of mathematics discrete math. It's technically discrete mathematics, but discrete math, that's like one of the branches. Like arithmetic is a branch, algebra is a branch, geometry is a branch, trigonometry is a branch, calculus is a branch, statistics could be considered a branch, but discrete math is another branch of math, which we're going to deal with a little bit. And this one deals more with logic.
And topics.
And topics about logic, statistics as well. So technically statistics is under discrete, but you can classify it in its own. Logic, statistics, and sequences fall under that. So sequences is another type of discrete mathematics. And does anyone know what a sequence is? How do you kind of define that? It's easy to see and identify, but how do you define it? Yep.
Kind of like a third and order conjugation.
Okay, yes, you're getting it. We're going to define it in our class as a list of numbers. It could be shapes or it can be objects, but a list of numbers in a certain order. So not just randomly placed, but in a certain order. And sequences are all over the place. In fact, you are made of many sequences. DNA sequence, there's a specific set of data that programs who you are. And it's way more complicated than any computer, tablet, phone, mega processor. None of those compare to your body and what it's doing all the time, which is amazing. Because you've seen even androids out there and human type interfaces. They're good and it's really kind of realistic, but they're fake in many levels. It's hard to replicate what's going on with your body because your body was made in a certain image. And this image that you're reflecting reflects something great, really awesome. And that's why we say we're all created in God's image, and that means something. 2, 5, 8, 11, and 14. ... Write that sequence down, please. So this is a list of numbers in a certain order. And does this sequence end according to this?
No.
Right. No, it has ... It keeps going infinitely. Does it have a first? Does it have like a first term? Does it have a first number? Yeah, what's the first number here? Everybody? 2. It's this one. Does it have a last number?
Yes. No.
Yes, it does. We don't know it.
According to this, it does not. So if I had, and it's possible, if I had ... here, it would not have a beginning. If I have ... here, it does not have an end. And some sequences will have no beginning or end. And we've already looked at them. Ready? Do you remember the set of integers? It's all the whole numbers and their. So does that pattern or does that order ever end? No, so that would be no beginning, no end. What about whole numbers? Does that have a beginning? Whole numbers. Yeah, 0 is the first one, and then it goes infinitely in that direction. Okay, but anyway, let's look at this sequence here. And I'm going to give you a couple of vocab words that you need to know. This right here, and this right here, and this right here, and that right here, and this right here, without saying the word, they are all called terms. Okay, this is a term, and term. Oh, I want to say a vocab word to avoid using term, but yes. Yeah. The term is terms. Yes.
This is just kind of a guess, but wouldn't a pattern be adding 3 each time?
Yes, and actually what we're going to do is this. You're going to see that from 2 to 5, you added 3, right? From 5 to 8, you add 3. So go ahead and write this down real quick. You're going to get it. The point of this lesson is to find that pattern, and you're going to be able to find like the next 3 numbers in this pattern, okay? So that's not too bad. But I can also ask you, all right, I have the first term, the second term, the third term, the fourth term, and the fifth term. I need you to find me the 303rd term. And you can find it using an equation that you can come up with. So you can also find it by actually literally writing all of them down. And I think all of you are capable of doing it, but man, that's a lot of paper and a lot of writing. And if you make one mistake, you're off. You're pretty much off. You can accidentally get it still, but you're pretty much off. That would be sad.
Are we going to do cool sequences like -5 plus 3 times 2?
You can get those. Yeah, it's possible. Not necessarily right now, and I don't know if I have time, but we'll get there. Not possible. Not this time. But let's get the basics here. Terms. First term, second term, third term, fourth term, fifth term. You guys hear me? Okay. What is the sixth term in this sequence? What's the sixth term in this sequence? Elizabeth. 17. That's over here. Actually, I wouldn't write those anymore, but we'll just leave it there. What's the seventh term? Josie. Eighth term. Callie. 23. All right, and it keeps going, dot, dot, dot. All right, so you guys get what I mean by first term, second term, third term, fourth term, fifth term. 330th term, way out there. There's a term. I don't know what it is, but we can figure it out. That's later. Okay, one of you brought up that you're adding 3 to each side. And I have something that I want to explain to you. And if you're listening, you can get it better. And you can ask better questions even if you don't get it. Okay, this plus 3 every time, it is called the common difference. Just write that down. And you're like, start to wonder. I said adding 3 is the common difference. Yeah, what does difference normally refer to? And I said this is adding 3, so that's confusing me. Maybe some of you it's also confusing, but this is how I'm going to explain it, and I'll do it a different way if I see that. So give me feedback. If you don't get it, just kind of look at me blankly. If you do get it, give me a nod. If you don't get it, just give me feedback. I need it on this part. Okay, the common difference we would say is positive 3. Okay, that's what I'm saying here. Okay, so I haven't explained it yet, but you're paying attention for the explanation. What is 5 minus 2?
3.
What's 8 minus 5?
3.
11 minus 8?
3.
14 minus 11?
3.
Okay, and do you see that the common difference is always 3 if I do that kind of subtraction? Now, why couldn't I have just said the common sum, right? Can't I just say common sum?
No.
Well, if I say common sum, what's 2 plus 5? 2 plus 5, 7. Okay, let's see. 5 plus 8? 13. 8 plus 11? Wait, there's no common sum. There's no such thing as a common sum. Not here. But is there a common difference between these numbers, these numbers, these numbers? It's that. It's positive 3. Can it be negative? Can the common difference be negative? And the answer is yes.
Wait, but it could be a common sum if your sequence was 1, 2, 3, 4, 5, 6, 7.
Yes, it could be. It's possible. But for these, you want cool ones, right? They're not going to be. So. Nice. Okay, yes, Marissa.
So to find like 330 and stuff, you just subtract 3, right?
We'll find it out. Keep thinking. All right. You need to know what a common difference is and what a term is. And then this is the definition of a special type of sequence that we're looking at in this lesson. It's called an arithmetic sequence. Now, I've mentioned the word arithmetic several times. You used to do a lot of arithmetic in elementary and even a little bit into like 5th grade, maybe in 6th grade. And then you start looking at it algebraically, okay? But arithmetic, in this case, is going to mean, for a sequence, the difference between any two consecutive, and I'll define some words to help you out if you don't get it, between any two consecutive terms is the same. The difference between any two consecutive terms is the same. So write that down. I'll go back to the sequence to help you to see what that actually means.
I was about to say, it's not true, but then they said consecutive.
There you go. And that, every word means something in this definition. All right. I think you guys are okay. Let's look back at the sequence. Okay, what do I mean by consecutive? Does anyone know what consecutive means? Yes.
Back to back? Or just,
Yeah, back to back. Okay, are these two terms back to back?
Yes.
Okay, so what's the difference between 2 and 5? What's the difference between 2 and 5? 3. So that's 3. What's the difference between these two consecutive terms? These two consecutive terms. Are these two consecutive terms? No. So you can see between any two consecutive terms, the difference is? Okay. What reasoning did I use to figure all this stuff out? So look at the sequence, and what you're going to be doing is you're going to find the next 3 terms, for example. What reasoning are you going to use? Jensen. Inductive. Okay, inductive reasoning. Because did I give you the rule yet? No, you guys gave it to me, and you got it by looking at each term, right? You can do that, and that's inductive reasoning. So that's the title of that lesson. Let's look at example 1, and let's see how we're going to use it here. All right, example 1. State whether each sequence is arithmetic, then write the next 3 terms of each sequence. So example 1, and we'll go with example 1a. They give us 1.25, 1.45. So yeah, write this down, please. 1.65. 1.85 and 2.05. ... Or they don't even give us a ... They should have given us a ... but that's okay. Actually, no, they should give us a ... because they said give me the next 3 terms. But they first want me to state whether this is an arithmetic sequence or not. So do these consecutive terms have a common difference? What's the difference between these two? 0.2, or yeah, you can say 0.20. Yeah, but you could do 0.2 is still okay. What's the difference between these 2 terms? 0.2. Between these two? These two? Okay, 0.2. Do they have a common difference? Is this an arithmetic sequence? Yes. The answer is yes. That's part of your answer. You just determine whether it's arithmetic or not. If you have a common difference, that means it's the same difference. Then it's an arithmetic sequence. And now I need the next 3 terms.
So if it's like plus 0.2, plus 0.3, then like that's not
Not arithmetic. It is a sequence, but it's not arithmetic. And there are other types of sequences. We're looking at arithmetic. Do you know the next term after 2.05? Or do you have a question? 2.25 is the next term. What's the next one? Sophie? 2.45. And last term, Emma Grace? 2.65. 2.65. So this is your answer. Okay, not too hard, I hope.
Would you have to put ...
No, because it just says state the next 3 terms. So that's all you have to put. All right, that's example A. Example B. Now we have 1, 3, 7, 13, 21. 1, 3, 7, 13, 21, ... Okay, is this an arithmetic sequence or not? So you're going to put yes or no, and I need a reason why or why not. Caroline, what do you think? Arithmetic or not?
I don't think it is.
What?
Because it doesn't have a common difference.
Really? Okay, what's the difference between these 2? Plus 2. Here? Plus 4.
6.
Let's see.
Oh, it's times 2. Right? No.
I think you're going to get to something I'm going to show you in just a moment.
It's plus even numbers.
Plus even numbers. So is this a common difference?
No.
It's not. Yeah, and remember,
Because there's a pattern doesn't mean it's
arithmetic. So a sequence doesn't have to be arithmetic, but we're determining whether it is arithmetic or not. So is this a common difference? No, not arithmetic. But can you find the next terms? 3 terms. What do you do to this one? Add plus 10. You get your 31. And then you're going to, so I'll put 31 here to get the next one. Plus 12, and that's 43. And then the last one, plus 14. Yeah, 57. So 31, 43, 57. And it's interesting because whether you determine if it's arithmetic or not, you still want to write the next 3 terms, so you can still figure it out. Not arithmetic, but it is a sequence, and those are my next 3 terms. You guys okay with that? So when I say common difference, I mean it has to be the same. But do you notice anything about the common difference?
Yes,
There's a
yes.
pattern in the common difference.
Plus 2.
You're adding 2 more each time. Okay, there's a pattern with the pattern. That's the.
Can there be a pattern with the pattern with the pattern with the pattern?
And then with the pattern again?
Yes.
Yes. Okay, that's where you're starting to get into cryptology, where your patterns are so deep that you have to have somebody who's very smart with a lot of time to figure it out. And you don't want them to figure it out, so you keep putting more patterns that they cannot break. Yes?
Can't you find the common difference for the common difference?
Yeah, so here,
That would be 2. That would be.
but yeah, so that common difference of the common difference is another idea. But yeah, the actual the actual differences are these, so they're not common. But you could find that there's something in common with those, and that would give you another layer of a sequence. C. Oh. C, this one gives you 13, 8, 3, -2, -7. All right, the common difference here is something else, and I need you to be careful. What's the difference between 8 and 13, or 13 and 8, and you have to say it correctly. We'll end with this. -5. Now let me show you here. So what's 8 minus 13? -5. Or if you're like, how do you know if it's negative or positive? This is how you deal with it. How do I go from the first term to the second term? I have to. Okay, look at this one right here. How did I go from the first term to the second term? So you see how, and do you see this? Addition, subtraction are very close.
So on B, if you win
Goodbye.